Hello, everyone. My name is Rob Schultz, and I would like to welcome you to the 2020 AdvanceKentucky AP Computer Science A mock exam scoring session. That is definitely a mouthful to say. I am going to start by sharing an agenda with you of what we're going to cover over the next 30-ish minutes, starting with, let's see, I'll introduce myself. We'll talk about just in general the questions and rubrics, what we know from College Board, or I guess what I knew at the time I put all this together and what we know now. We'll get into some detail with question one, the flight list question. We'll talk about the question itself, the rubric, and we'll look at some student samples. And question two, the self-divisor question, we'll look at the question, the rubric, and some samples. And I'll mention this again later, but unfortunately there were no student submissions for this mock exam. So as with pretty much everything you're going to see that I'm sharing with you, not only are the questions that I pulled, the rubrics are rubrics that I somewhat modified from the College Board rubrics that went with these questions. We'll talk about that. But the student samples are also my best guess at what some student responses to these questions might be, since there were no actual student submissions. So first, to introduce myself, my name is Rob Schultz. I am a teacher at Bellbrook High School in Bellbrook, Ohio. I've been teaching at Bellbrook for 20 years, teaching both math and computer science, although now I'm focused pretty much all the time on computer science, and I've been teaching AP Computer Science A for 19 years. I've been involved with the AP reading since 2008. I've served in the capacities since then of reader, table leader, and question leader. I've been a College Board consultant since 2017, and I've been involved with AdvanceKentucky since 2018. And I feel somewhat obligated at this point to show it, to throw in a little disclaimer, because College Board tends to get a little, not really upset, but they don't appreciate it when College Board consultants represent themselves as College Board consultants at non-College Board workshops. So, oh, and I just realized there's a typo on my slide. Nice. So I wanted to point out, this is not a College Board workshop. These are not College Board workshop materials, and I am not here today as a College Board workshop consultant. I'm only here sharing my experience with you as a veteran AP Computer Science A teacher who has some past reading experience. So hopefully the things I can share with you will provide a little insight and my best guess at how things are going to look, so that your students have some things to practice with. Looking at the information about the questions and the rubrics, at the time I put all this together, which was about 2 or 3 weeks ago, College Board had just announced the changes that were going to happen with the exam this year in kind of this unprecedented situation that we're in. The exam was going to be modified so that students can take it from home on any device, 2 questions instead of 4, no multiple choice. Question 1 was going to be an array list question, or is going to be an array list question, counting as 65% of the student's score, with 25 minutes for the student to complete the question. And then question 2 is going to be a methods and control structures question with worth 35% of the student's score and 15 minutes to complete the question. And then College Board also announced that there would be an open-ended question at the end of each one of these other questions. And that was really the true wild card, because they didn't really at the time have any description of what those questions might look like. I know that's been a big question in the online teacher communities and in the Facebook groups as to what those questions would actually be and how they would be formatted and how they're going to be graded. Well, since putting all this together, College Board on, I want to say May 1st, and I have that information on a later slide, but College Board released sample questions of what this actual exam's questions might look like, and they included open-ended sample questions, samples to the open-ended questions. So we'll talk more about the open-ended questions as we go. I will be honest with you, I'm not going to be sharing a lot of information about my open-ended questions or the guesses that I came up with or the rubrics that I put together, because again, with College Board releasing just recently what those open-ended questions would look like, it makes my questions somewhat obsolete. And because there were no student submissions, which required me to use the rubric I came up with, it makes my rubric also obsolete. So we'll talk about that more as we get into this. As far as picking the questions are concerned, to model what College Board was saying the questions would look like, I wanted to find an array list question, and I also wanted to find a methods and control structure question. I wanted to make sure they were good representations of what students will see on a College Board AP exam. And in my own classroom, when I give questions that I want to be equal to what students might see on the AP exam, the best place I know to go is past AP exams. And every year College Board releases, after the exam is taken, they release the free response questions. So they're available on College Board's website. After the reading, they also release the canonical solutions, the scoring guidelines, student samples, and different things like that. So all of that information is readily available to students, teachers, parents. I mean, anybody that would want to look without any kind of required login or identifying yourself as an AP teacher. So I'm not really pulling anything that would not be already public. I also wanted to make sure I was going back far enough in looking at all the past released free response questions, so that if there are students that are looking at current questions for practice, or if there are teachers that are using current questions for practice, that I'm going back further than things that students might have already seen. So I started looking at 2010 and then kind of moved forward from there. And so I ended up with question 1, the free response question 1 from 2008 for the array list question, because I like the fact that it focuses on accessing elements of an array list. It requires students to traverse an array list and use existing methods. And then for question 2, I picked free response question 1 from 2007. And because this is a shorter question, students only have 15 minutes, I eliminated part B from that question. And I also like the fact that this question relies heavily on the use of loops, conditionals, and this modulus operator, which is something that my students are surprised when we cover modulus, how frequently modulus pops up in different problem solutions that we look at. And then, like I said, the open-ended questions were kind of a wild card. The things that I had posted, and when you go out and look at the questions for this mock exam, if you did share those with your students, again, those were just my best guess. Rob Schultz's personal best guess at what those open-ended questions would look like, because at the time I put this together, those hadn't been released by College Board yet. So let's see. I also wanted to make sure to point out that I adapted the rubrics. I eliminated half points. The reason I'm adapting the rubrics instead of using College Board's released rubrics is because back in 2008 and 2007, half points were used in the scoring, and that's a practice that has been eliminated. We no longer count half points. So I didn't want teachers to have to use a rubric that's no longer consistent with the way questions are scored today. So I went back and modified the rubrics to eliminate half points, and it meant grouping some things together. So hopefully my rubric isn't more strict or I guess more dependent on certain things than the rubric in the past. But again, I wanted it to be a more realistic looking rubric for when you work through it with your students. So let's see, question 1, I set up the rubric so that it focuses again on accessing elements of an array list, making sure students know how to traverse an array list and use existing methods. And for question 2, again, it focuses on the use of loops and conditionals and being able to process digits of a multi-digit number. And again, that's where that modulo comes from. And we've already talked about open-ended questions, so I'm going to go ahead and move on from there. So question 1, specifically the flightless question. So when we look at the flightless question, the question revolves around a travel agency that maintains a list of information about airline flights. And the question explains that flight information includes a departure time and an arrival time, which makes sense. It says that you may assume that the 2 times occur on the same day. So they're not going to throw us any kind of a curve like a flight that departs at 11 p.m. and arrives at 1 a.m. And it says these times are represented by objects of the time class. And then they show us the declaration for the time class. And it includes a method called minutes until that returns the difference in minutes between the current time object and another time object. So they give us a little demo down here of what the method header for minutes until looks like. Sorry about that. And then they also give us a sample, and they tell us that if T1 and T2 are time objects where T1 represents 1 p.m. and T2 represents 2:15 p.m., the call T1.minutes until T2 would return 75 because there are 75 minutes between 1 p.m. and 2:15 p.m. On the other hand, if I call T2.minutes until T1, then there would be negative 75 minutes to work backwards from 2:15 p.m. until 1 p.m. So that's how minutes until work. And one of the things I tell my students is anytime in a free response question, if they give you a class or if they give you methods that say implementation not shown, that's immediately a red flag that, okay, we're going to have to use this method somewhere in our solution. So we can kind of file that away that we're going to have to use minutes until at some point in solving this problem. They also give us the declaration for the flight class, and it says that the flight class has methods to access the departure time and arrival time, which are going to return time objects. And it also says you can assume that the departure time of a flight is earlier than the arrival time. So again, they're giving us some preconditions. They're giving us some preconditions for expectations for this class. Let's see. Okay, so we also have some additional information. It says a trip consists of a sequence of flights and is represented by the trip class. The trip class contains an array list of flight objects. So this is where our array lists come into our array and array list question. And it says that flight objects are sorted in chronological order. So they give us, let's see, they give us two methods. The first method is going to return an integer, and it's called get duration, and that's the one that we're going to complete in part A. And then they give us a second method header that's going to return an integer, get shortest layover, that will complete in part B. So let's focus on the get duration method. Now, I also tell students that you can't just read the problem and not read the preconditions and the information that comes with the actual method header. This method header includes comments that say that we're going to return the number of minutes from the departure of the first flight to the arrival of the last flight if there are one or more flights in the trip. So in other words, I'm going to take, no matter how many flights I have in a trip, I'm going to take the departure time of the first one and the arrival time of the last one. And I'm going to calculate the number of minutes that we need to get from the starting point to the ending point. It also goes on to say that it's going to return 0 if there are no flights in the trip. So that's something we need to make sure we take into account. So here is the canonical solution. Now, like I said, the canonical solutions, the scoring guidelines, everything that was used back in 2008 are available on College Board's website. And this is the 2008 canonical solution. This is my modified Schultz rubric that eliminates half points. So the first point is to check if flights is empty and return 0. And our canonical does that. The very first thing we do is we check to see if flights.size equals 0. And if it is, we automatically return 0 and we're done. The second point is for accessing flights.getZero and correctly calling get departure time. We have to get the first flight in our trip and figure out what the departure time is. That's our starting point. We have to access flights.get flights.size -1, in other words, the last flight in our trip, and correctly call get arrival time. So that's our ending point. And then for the last point, we have to return the correct duration using minutes until. So this is where we have to use that method that was thrown in back in the time class that we said, okay, there's our red flag. We have to take our starting point, minutes until the ending point, and return whatever the minutes are to get there. Now, for each one of the problem sections that I gave for the students, or that I put together in this mock exam, I wanted to give a couple of sample student solutions. And like I said, unfortunately, there were no actual student submissions for the mock exam. So this is my best guess based on past experience from the reading and in my own classroom, the common mistakes that students might make. So looking at the modified Schultz rubric for this thing, the first point is a point to check if flights is empty and return 0. Well, in this case, the student missed that point in the problem description. They didn't see that perhaps, or maybe they just got in a hurry and forgot about it. But we have to have a check in there for it. And because there's no check in this solution, the student wouldn't get the first point for this one. From that point on, everything else is pretty much the same as the canonical. We access flights.getZero and we correctly call get departure time. We access flights.get flights.size -1 and we correctly call get arrival time. And we return the correct duration using minutes until. So for this solution, even though that first section was missing, this would still score 3 out of 4 points. Looking at a second sample student solution, let's see. For this one, we check if flights is empty and return 0. So that's true. The student did do that. But for this one, notice inside the else statement, the student tried to put everything in one line, which is possible. It is possible to do a solution that does that, but that's a lot of information to include in one line. And the more information you include in a line, the easier it is to get lost in there as you type it and forget certain things. So in this case, as we look down through the rubric, does the student access flights.getZero and correctly call get departure time? Well, in this case, they don't. They looked at flights.getZero, so they're looking at the first flight in the trip, but they forgot to call the get departure time method. So it almost appears in this case that the student was looking at flights.getZero, assuming that it would return the departure time. So they wouldn't get the first point because they didn't correctly call the get departure time method. For the third point, they access flights.get, but instead of doing flights.size -1, they do flights.size, which is going to cause a problem. if we have 5 elements in our array list, if we have 5 flights in our trip, they're going to be indexed to 0, 1, 2, 3, 4. So if I call flights.size, it'll return 5. If I try and get what's at position 5, it's going to throw an exception because now I'm out of bounds. So I can't call flights.get flights.size without throwing an exception. And the second problem in here is that, as with get departure time, they also forgot to call get arrival time. So even though they made 2 mistakes in this spot, both of those mistakes are tied to this 1 point. So for 2 different reasons, they would lose this 3rd point. They wouldn't lose a point for each mistake. They just lose 1 point tied to the rubric for both of those little issues. And then the last problem, do they return the correct duration using minutes until? Well, unfortunately, because minutes until is a time method, it's a method in the time class, I can't call minutes until on a flight, which is what flights.getZero will return. And I can't pass a flight, assuming this wouldn't throw an exception, I can't pass a flight into minutes until as a parameter. They have to be timed. So because I'm not correctly using minutes until with time objects, I can't be returning the correct duration using minutes until, which means I wouldn't get the 3rd point. So in trying to save space maybe, or save time, or consolidate code, the student tried to put everything in one line, but because they forgot multiple things and made several mistakes in that one line, they ended up costing themselves 3 points. So this, again, based on my interpretation of the modified Schultz rubric, this would earn 1 out of 4 points. Now, like I said, it is possible to return, to pack all of this into one line, and to do that, it would look something like this at the bottom. But you know, we have to go to the flights array list. We have to get what's in position 0. From that flight, we have to get the departure time, and then using that time, we have to call minutes until. And then in the parameter list, we have to go to flights and get flights.size -1. And once I've got that flight, then I get arrival time. And that's a lot of margin for error inside that one line for a student to get lost in all that and forget something somewhere. So my recommendation to my students would be to kind of look at the way the canonical is laid out and then modularize your code. You know, I tell them that modularizing code doesn't mean we break chunks of code into methods necessarily. It could mean taking one big line of code and breaking it into smaller, more understandable lines of code that are easier to track and troubleshoot. So just again, a word of advice as you're talking to your students about some of these little issues that might pop up. So that's what I have for part A. Let's look at part B. So part B says we're supposed to write the trip method get shortest layover, and it says a layover is the number of minutes from the arrival of one flight in a trip to the departure of the flight that immediately follows it. It says if there are 2 or more flights in a trip, so that's, again, something that the student's going to have to make note of. If there are more than 2 flights in a trip, or 2 or more flights in a trip, the method should return the shortest layover of the trip. Otherwise, it should return -1. And again, that's going to be an easy little couple words in there for the student to miss as they're reading through it. So looking at this example, let's say this is our array list of flights. The flights are indexed 0, 1, 2, and 3. Each flight has an arrival time and a departure time. Arrival time, departure time. And when we look for layovers, the layover is the time from the arrival of the first flight to the departure time of the flight that follows it. So the layover between a flight that arrives at 12:15 and the next flight that leaves at 1:15 would be 60 minutes. If I have a flight that arrives at 3:45 and the next flight leaves at 4 o'clock, then that would be 15 minutes. And so on and so on. So if I were to call get shortest layover on this method, it would return 15 because I have more than 2 flights and the shortest layover would be 15 minutes. So here's the canonical solution for this one. Again, this is the original 2008 canonical solution. I like the way this canonical is laid out. Again, it kind of steps through the rubric, and this is again pretty close to the regular rubric, but all I did was eliminate and kind of consolidate the half points. So we now have 5 points. The first point is to check if flights.size is less than 2 and return -1. The second step is to access all of the elements of flights with no bounds errors, and we do that. So our for loop goes from 0 up to flights.size -1, and then within the for loop, we reference the elements at position I and I plus 1. So when I equals 0, we're going to go from the beginning. We'll make sure we get position 0. When flights is equal to, I'm sorry, when our object, or I should say, is equal to flights.size, When we get to the point where I is approaching flights.size -1, the I +1 will make sure that we actually get all of the elements that are required. So we are good to go there. I'm kind of tripping over my tongue here a little bit on the recording. The third point, do we compare the layover time between successive flights using minutes until? So again, here's that minutes until method. So we have to kind of use minutes until to figure out what the time is between the arrival of one flight and the departure of the next. And we do that. We compare layover time between successive flights, I and I +1, using minutes until, and we have a comparison. And do we correctly identify the shortest layover? We do. If layover is less than what we've identified as the shortest, then it becomes the shortest. And finally, do we return the shortest layover? We do. So again, I wanted to come up with a couple of student samples that might show some common mistakes. So take a couple seconds and look at this one. Looking at the modified rubric, the first point, do we check if flights.size is less than 2 and return -1? Well, unfortunately, we don't. Again, this is one of those cases where maybe the student was reading too fast or they missed that little detail. So we don't earn the first point of 5. Do we access all of the elements of flights with no bounds errors? Yes, we do. Everything looks okay there. Do we compare the layover time between successive flights and minutes until? Everything's looking okay with that one. Do we correctly identify the shortest layover? Yes. But when we get to this last point, do we return the shortest layover? This is a surprisingly common error, both in my own class and from what I've seen over the years at the reading. It's very common for a student to have a method that's supposed to return a value and then just accidentally forget to put the return at the bottom. So one of the things I tell my students is before they finish a method, just kind of go back and double check the header, make sure that they've got the required parameters, make sure they've got the required return type, and then based on the return type, are we returning what is expected? And in this case, hopefully looking at the fact that this has an int return type would clue us in that we're missing something down here because there is no return. So again, just one of those little mental checklist things that as you finish a question, do I have everything that I'm looking for? So here's sample student solution number 2. Take a couple seconds and look it through, see if you can see the difference, because this is very, very close to the canonical. In this case, the student would get the first point because they check to see if flights.size is less than 2 and they return -1. But take a look at the for loop. We run into a problem with accessing all of the elements of flights with no bounds errors, because one of the things that we impress upon our kids, we spend so much time practicing traversing strings and traversing arrays and traversing array lists. Generally, at least in my own class, I'm guilty of this. 95% of the problems that I give the students require that they go from the first element to the last element. So we get in this habit where our loop control variable starts at 0 and it goes up to flights.size. And sometimes we lose sight of the fact of what's going on inside the loop might mean that we don't necessarily want to start at 0, or as in this case, we don't necessarily want to go all the way to the end. If I go up to flights.size, that means if I have 5 flights, I'm going to go up to position 4, and flights.get4 will work okay. But when I do flights.get4 + 1, it's going to look for position 5, which is going to throw an exception. So I have a bounds error with this one, which means that I wouldn't get that second point. I do compare the layover time between successive flights using minutes until. I correctly identify the shortest layover, and I return the shortest layover. So this particular student with this specific error, because of the exception, because of the bounds error, they would lose the second point. Okay. Like I said, I had an open-ended question. I'm going to talk about the online teacher community for just a second. So if you're kind of fast forwarding through some of this, like I said, 2 to 3 weeks ago when I put all this together, the only thing we knew about the exam was that it would have an open-ended question, and there was really no information about what that open-ended question would look like. So I gave my own personal best guess at what that open-ended question might entail. I had 2 different directions that I kind of anticipated that it might go, and being honest, one of them was fairly close, the other one not so much. But since then, College Board released on Friday, May 1st, a draft of sample questions that would be similar to the questions asked on the 2020 AP Computer Science A exam. And this draft can be found at AP Central in the AP Computer Science A online teacher community. it includes samples of the open-ended questions. So for a couple different reasons, because my guess is now obsolete since we now have information from College Board, and because my rubric wasn't actually used to score student samples, there were no student samples submitted, there isn't really a need to actually go through my best guess at what the open-ended question or the rubrics would look like. So what I am going to say is I'm going to encourage you to go to AP Central, to log on to the online teacher community and pull up the questions that were released by College Board. And if you are not a member of the online teacher community at AP Computer Science A's, the AP Computer Science A online teacher community, please join, because it's College Board's first and foremost way. It's their method of sharing information with us as teachers. So I know there are some Facebook groups, and there are even some College Board personnel that belong to those Facebook groups, but this is the official channel for College Board to share information with teachers. So my recommendation would be to get your information from the online teacher community. Okay. Pardon me. Okay, looking at question 2, the self-divisor question. For question 2, like I said, this is a 15-minute question as opposed to the previous question, which allows 25 minutes. Because it's a shorter question, I trimmed part B from the question that was originally asked in 2007. But the original question was worded in such a way, I've got a little line that didn't disappear when it was supposed to. It says a positive integer is called a self-divisor if every decimal digit of the number is a divisor of the number. That is, the number is evenly divisible by each and every one of its own digits. And they give us an example. There we go. Now I get to use that little line that I left in. The number 128 is a self-divisor because it's evenly divisible by its own digits, 1, 2, and 8. However, 26 is not a self-divisor because it's not evenly divisible by the digit 6. Okay, so we're looking for numbers where each of their digits are a divisor of themselves. It goes on to say that note that 0 is not considered to be a divisor of any number, so any number containing a 0 digit is not a self-divisor, and there are infinitely many self-divisors. So as I look at the declaration for this class, we have a self-divisor class. We have a is self-divisor method that we're going to implement in part A. They give us a precondition to tell us that number has to be greater than 0. So I'll never get a negative number. I'll never get 0 as a number. The number will be 1 or higher. And then notice there is a second method down here, first num self-divisors, and that was originally in 2007 to be implemented in part B. Well, because I'm formatting the question for the current exam, I eliminated part B. So we don't have to worry about this first num self-divisors method for this mock exam. Okay, so looking at the is self-divisor method, let's see, I think the canonical's up there. Okay, so this is the original canonical solution from 2007. And then here is the modified Schultz rubric. The first point is to access the digits in, access a digit in the context of a loop. So 2 different ways that you could do that. One would be to use number modulo 10, or the second way would be to successfully convert the number to a string and then use either substring or charat to get each individual digit. But then once you have it, then there's some manipulation or conversion back from a string or a char to an int. So I decided to kind of stick with the int solution because, again, I feel like this modulo is an important concept that our students should know. And if by some chance you're not comfortable with modulo, or maybe your students aren't comfortable with modulo, remember that modulo is basically remainder. If I have 324 modulo 10, 324, thinking in terms of long division that we did back in elementary school, 324 divided by 10, 10 is going to go into 324 32 times, and I'll have a remainder of 4. So what that tells us is 324 modulo 10 is going to give us 4 as an answer. It essentially just strips off the last digit, the digit on the far right of an int, so that I can see what that last digit is if I use mod 10. So in this case, the student does access a digit in the context of a loop using number mod 10. They correctly process all of the digits. Now, this is where I'm going to throw in that this is my interpretation of my own rubric. So to me, correctly process all digits means that we take a number. While that number is greater than 0, we identify what we think is a digit, we do something with that digit, and then we get rid of that digit. So again, if I have 324, I'm going to get a digit, the 4, I'm going to do something with that digit, and then I'm going to come down here, and if I do 324 divided by equals 10, it's going to change into 32, because we have an int divided by an int, we're going to get rid of the decimal. So then 32 will be greater than 0. We'll identify the digit. In this case, it would be 2. We'll do something with the 2. And 32 divided by equals 10 will leave us with 3, and we can keep going. So when it says correctly process all digits, my interpretation on my rubric was that we take what we expect to be a digit, then we do something with it, we eliminate it, and we continue until we've done that with what we perceive to be all digits. Okay, so the logic behind making sure that works is what I was looking at. For the third point, do we test if it's divisible? We need to make sure number is divisible by the digit, and we're going to do that using modulo digits. So 128 modulo 8 is going to equal 0. 128 modulo 9 is going to equal 1, which is not equal to 0, which means we return false because we have now found a digit that's not a divisor. Okay, so we are testing to make sure that number modulo digit is a true statement. We're checking to see if it's divisible. And then the last point of our 4 points for this part, do we return false if we find a 0 digit or a non-divisor? And do we return true otherwise? Do we return true if our number is a self-divisor? So again, I wanted to show you a couple of student solutions. Here is sample student solution 1. So the first problem, do we access digit in the context of a loop? Well, this is a student that maybe isn't comfortable with what modulo does. So their logic is correct. They think they're identifying a digit. They're even calling the variable digit, but instead of using modulo, they're using division. So they're not going to get what they think they're going to get. So unfortunately, they're not going to get this first point because they're not correctly using modulo. They're using division instead. Do they correctly process all the digits? Well, again, because it's my rubric and my interpretation, it's easy for me to say yes. Based on my interpretation of this rubric, they are correctly processing all the digits. They have a number, that number is greater than 0. They're identifying what they believe to be a digit, they're doing something with it, and then they eliminate it. So n divided by equals 10 will eliminate the last digit and continue to work through that way. Okay, so the logic of what they're doing is correct, even though they're doing it incorrectly, I guess is what it comes to. For the third point, do they test if divisible? Well, again, this is an issue with not using modulus. They can do number divided by digit, but it's not going to return a correct test for divisibility. So they're not going to be able to determine whether number is truly divisible by digit by using division. They have to use modulus for that. So they would not get the third point. But based on their logic, they do return false if they find a 0 digit. They have that check built in. If they find a non-divisor, or if they make it through the entire while loop, their logic is relatively sound. So in this case, based on my interpretation of this rubric, they would get 2 out of 4 points. Okay, and I know I keep saying based on my interpretation. I know there are some teachers out there that would look at this and say, well, you know, they did modulo wrong, which is going to cause all of it to be wrong, so they're going to lose all 4 points. There might be other teachers that say, well, we already took a point off for modulo on the first point, so why would we take modulo off for the second point? And you know, those are all things that at the actual AP reading would have been discussed and maybe debated, and if necessary, the chief reader would have made a decision that if a certain error is made, where would the point be? So in this case, because I'm the reader, the table leader, the question leader, and the chief reader for this, you know, little video, that's the call I decided to make. So hopefully that makes sense. All right, a second student sample solution. We have a student that correctly used modulo to identify a digit. They're using number modulo 10 correctly. They are correctly processing all of the digits. They test to make sure that number modulo digit proves that it's a divisible number, and they return false if it's not. But the one thing they forgot, and again, this goes back to reading the question and making sure you're not in too much of a hurry, is that they forget to put in a test that will return false if they find a 0 digit. So in this case, because they didn't put in that test to make sure that digit is not equal to 0, they would lose this last point because they're not returning true or false in all of the necessary cases. So they would lose that last point. So they would get 3 of the 4 points. Again, there was an open-ended question attached to this one, but we've already kind of addressed this. Again, I can't stress this enough. Please go out to the AP Computer Science A online teacher community and reference the sample questions for the 2020 exam that were released by College Board. They are a much better representation than my best guess. If you are not a member of the AP Computer Science A online teacher community, I would strongly encourage you to register an account and join the online teacher community. Hopefully, everything that we went through made sense. I wish this was a synchronous communication so that we had time for some questions. If you had any questions, unfortunately, it's not. So I guess this is where I bring things to a close. So I guess in closing, I wish all of you the best this year, and in future years, I wish your students nothing but the best on the upcoming AP Computer Science A exam on May 15th. Believe me, I will be thinking about all of the students sitting at home trying to work through this exam in our current situation. Good luck to everyone, and I hope to see everyone next year. Everybody take care.